Okay, guys, so in this section, we're going to talk about radical equations and problem solving. So the big part of the section will be learning how to solve a radical equation. You already know how to mess with radicals a little bit from the last either course you took or from high school or whenever you last worked with radicals in terms of square rooting. So just a little quick review. So if you guys were asked to simplify the following, okay, and I gave you the square root of 8. Now, you guys know that the square root of 8 is actually an irrational number, okay? But in order to simplify the square root of 8, you have to find out how many square roots are in there. So the way the book actually would teach you is they would say, well, 8 is really the square root of 4 times 2. This is using the product property of radicals, where you're now going to say this is the square root of 4 times the square root of 2. So you are allowed to split a radical through multiplication or division using the product property or the quotient property. The reason this is good is because then this becomes the square root of 4, which is 2 square roots of 2. Okay, so we could do the same thing with the square root of 72. So the square root of 72 is really 9 times 8, but we know that this is really, if we wanted to rewrite this, technically 8 is 4 times 2, so I could do the square root of 9 times the square root of 4 times the square root of 2. Because the square root of 9 is 3, that'll work out real good. We know 8 is 4 times 2, so that'll work out real good. So we're going to be able to say this is 3 times 2 times the square root of 2, which is 6 square roots of 2. So this is how we can clean up radicals. I personally do it this way. I say, well, since this is a square root, I need 2 of a kind. So this is 9 times 8. I don't have any pairs, so let me keep using factor trees. This is 3 times 3. This is 4 times 2. This is 2 times 2. So now what I do is I come along and I circle my pairs. There's a pair. So I'm going to take square root of 72 equals 1, 3 comes on the outside. Here's a pair. 1, 2 comes on the outside. What stays behind is that 2 because there's no tree under it. So this becomes 6 square roots of 2. This is how I simplify radicals. So just make sure that you're okay with simplifying radicals. If you need a little help with it, you can do the same thing for cube roots. You know, if you're asked for the cube, oops, that's way too big. If you're asked to find the cube root of, I don't know, what would be a good cube root? The cube root of 7, let's do the cube root of 72, okay? So the cube root of 72 is really the cube root of 9 times 8. Now, are either one of those perfect cubes? Well, 9 is not, it's a perfect square, but 8 is a perfect cube. So I'm going to do the cube root of 8 times the cube root of 9. The cube root of 8 is 2. The cube root of 9 is just the cube root of 9. So that would be the answer to the cube root of 9. If we do it my other way, I would say, well, this is 9 times 8. This is 3 times 3. This is 4 times 2. This is 2 times 2. So now instead of searching for 2 of a kind, the index tells me I'm searching for 3 of a kind. So here's 3 2s. I'm going to use them up. Put 1 on the outside. What stays behind is this set of 3s. Well, 3 times 3 is 9. Same answer, right? There's no difference. So either way is fine with me, but this is how you simplify radicals. If they ask you for an exact answer, you have to do this. You are not okay with decimal approximations unless the problem says use decimal approximations or round off, okay? So that's just a little quick review. Let me go back up there for you. That's a little quick review of how to simplify radicals. Okay, so let's go over here. Okay, so solving equations that contain radical expressions, and then at the end we'll use the Pythagorean theorem to model problems. So the Pythagorean theorem is something you've probably seen before. We're going to go over that a little bit at the end of the section. Okay, so the power rule says if both sides of an equation are raised to the same power, all solutions of the original equation are among the solutions of the new equation. Okay, sounds good. So let's see what that means for us here. So if I ask you to solve the square root of x plus 1 equals to 5, what I'm allowed to do is I'm allowed to cancel this, it's not really canceling per se, it's undoing a square root by squaring. But whatever you do to one side, you do to the other. So when I do this, I now end up with x plus 1. And again, if you're not sure why this happens, okay, if I took the square root of 2 and I multiplied it by the square root of 2, I would get the square root of 4, which is just 2. So whatever was underneath, because think about it, you're multiplying a square root times its twin, right? So that would be the same as saying the square root of 2 times the square root of 2. Well, isn't that just the square root of 2 quantity squared? So that would just, in a way, we do this in our minds, we cancel those out, and this just becomes 2. So now the same thinking goes for the square root of x plus 1 times the square root of x plus 1 would equal the square root of x plus 1 squared. So that would just be x plus 1, right? So that's how our thinking is going to go. And this equals 25, right? So now what we're going to do is we're going to solve. Okay, so we end up with x equals 24. So that's what we think our solution is. So now what we do is we have to check it. So with these in general, you should always check your solutions to make sure they make sense with the problem. So I'm going to say the square root of 24 plus 1 equals 5. So this becomes the square root of 25 equals 5. So 5 equals 5. We get our identity. It checks out. So this is a true statement. Okay, so 24 is in fact the correct x. Okay. So here's how we're going to kind of set up radicals, okay, or radical equations. You're always going to isolate one radical on one side of the equation, doesn't matter which. Once you've done this, you raise each side of the equation to a power equal to the index of the radical you simplify. So if it's a square root, then you square it. If it's a cube root, then you cube it. If it's a 2/3 power, then you 3/2 power it. You're basically trying to turn the exponent into a 1 instead of a fraction, or into, instead of a fraction, okay? If the equation still contains a radical, repeat steps 1 and 2. If not, solve the equation. So this is where you kind of have to make sure that you don't still have radicals left after you've squared, and that's for the harder one. So step 3 is for the much more difficult problems. Then after all this is done, check all proposed solutions in the original equation. Okay, so very important to check your work on these ones. Normally, you should check your work in general, but sometimes I know we all run out of time. With radicals, you have to be careful. Some extraneous solutions can sneak in, solutions that are not actually correct, and they can give us incorrect answers. So let's do step 1, isolate the radical in this problem. Okay, so we add 1. So we have the square root of x minus 1 equals 1. Okay, so now what do we do? Think about it as you're working with me together. We should square both sides, right? Because we have the radical isolated. See here, it says isolate one radical on one side of the equation. We did that. Raise each side of the equation to a power equal to the index of the radical. Okay, so that's what I did now. Let's see what we're left with. X minus 1. Remember, the radical and this kind of undo each other. They're opposite operations. And then we're left with 1. So now I'm going to add 1. So x equals 2. But now I want to check. Okay, so now I'm going to say the square root of 2 minus 1 equals 0. So this would become the square root of 1 minus 1 equals 0. And the square root of 1 is in fact 1. So 1 minus 1 equals 0. So it checks out, and it's a good solution. We'll take it. Okay. Okay, so let's move on. So this time I want you guys to pause the video and try this one on your own. So take a minute, pause the video, try to work through this using what I just did in the previous 2 problems, and let's see where you stand in a little bit. Okay, so hopefully you guys unpause the video now and you have something in front of you. Hopefully what you did first was what? We had to isolate the radical. So that means I must subtract 2x to both sides. Okay, so now I'm going to be left with the square root of x plus 1 equals 8 minus 2x. Okay, now according to our little technique, our steps, we're going to square both sides, and this becomes x plus 1. Now this is where people normally go wrong. Normally people do this, and this is 100% not what 8 minus 2x squared is. Remember, 8 minus 2x squared means 8 minus 2x times 8 minus 2x. You have to FOIL it out. Oops. You have to double distribute. Okay, so this is going to become 64 minus, what is that, 32x plus 4x squared. Okay, so that's actually what we have. Now we have to solve for x. So I'm going to move everything over. So this side is going to become 0, right? So 0 equals, now let's see here, 4x squared minus 32x plus 63. Okay, so let's see here. Wait a minute. Oh, 33x. Sorry about that. I made a little mistake right there. 33x. Now we have to see if we can factor. Okay. So let's go over here. Let's try to factor this. So we're going to do double parentheses. I'm going to set it equal to 0. Remember, you always, when you're factoring like this, you want it equal to 0, so you can use a zero product property. Okay, so we know that the factors of this, the factors of 4x are either 2x squared or 2x and 2x, or 4x and x. So let's try 4x and x, because we have to get to a pretty big number in 33. Let's see here. 63. Well, 63 is either 9 times 7. So if I use a 9 and a 7 here, that'll be 9. That won't get me close to it, because remember, one's positive, or actually they're both going to be negative, it looks like. Yeah, they'll both be negative. So we know this is a negative and a negative. Now 63, let's see what else we got. Well, that's 21 times 3. Let's do 21 and 3 here. Well, this would be negative 21x. That would be minus 12x. That would give us negative 33x. And this is a negative 33x. So once again, my preferred method is guess and check. So this turns out to in fact be the correct factors. Yeah, so let's set them each equal to 0. X minus 3 equals 0. So 4x equals 21 and x equals 3. So x equals 21 over 4 and x equals 3. So these are my solutions. Okay. Now what we're supposed to do next is we're supposed to check these. Okay. So let's come over here. Let's do the check. So 2 times 21 over 4 plus the square root of, let me see here, 21 over 4 plus 1 equals 8. So that would be 21 over 2 plus, now in here, this would be 4 over 4, right? 1 is the same as 4 over 4. So this would be 25 over 4 equals 8. Now we know that this is 21 over 2 plus 5 over 2. Let's see here. So we end up with, what's this going to be? 26 over 2, which is 13. So 13 equals 8. This is not true. So our 21 over 4 is actually a extraneous solution. This one is extraneous. That is an extraneous solution. And now let's try 3. I probably should have done them both in red. That way the check looks more. Let's do check on 3 now. So this would be 2 times 3 plus square root of 3 plus 1, better be 8. 6 plus the square root of 4 would be 2 equals 8. So 8 equals 8, checks out. So that means that this is our only true solution. Even though 21 over 4 mathematically solves this equation, it would not solve the original equation. So it is extraneous, okay? So once again, here's a harder problem. You guys pause the video. This would be the hardest one you'll see. Take a minute to pause the video and give this one a shot on your own. See what problems you run into. You're probably going to need step 3, okay? All right, so let's do step 1. Says isolate one of the radicals. Okay, one's already isolated. So we're going to do the square root of y plus 5 equals 2 minus the square root of y minus 4. Now we have to square both sides. So here's step 2. So y plus 5 equals, now we got to FOIL this. And remember, this means 2 minus y minus 4 square rooted times 2 minus square root y minus 4. That's what it means to be squared, right? So let's FOIL this out. This will be 4 minus 4 square roots of y minus 4 plus y minus 4. Okay, so all I did was I just did this and did this. Okay, and this is what I end up with. So now let's clean this up. Y plus 5 equals, what is that? Negative 4 square root y minus 4 plus y, right? So unfortunately, we still have a radical left over. So what this means is that we have to clean up our problem again. We have to isolate the radical again. So let's do this. Let's subtract the y, subtract the y. So we're left with 5 equals negative 4 square root of y minus 4. Okay. So now the radical, let's divide both sides by negative 4. Okay. So now let's come over here. So this would be negative 5 over 4 equals the square root of y minus 4. So we have isolated the radical. We have to square it once again. So that's what step 3 means, is repeat step 1 and 2. So we just repeated step 1 and 2 to isolate the radical, and now we're squaring it. And let's see what we have left behind once again. So this would be 25 over 16 equals y minus 4. Okay. Let's see here. Let's clean this up. Let's solve for y. So let's add 4, add 4. So when we add 4 to that, we should get, let me see, 16. So that would be what? 64 over 16 plus 25 would be 89 over 16 equals y. Okay, so we have 89 over 16 equals y. Let me see here. That looks pretty solid, but we have to plug it in, right? So let's come over here and let's do our check. I'll do it in red this time, like I should have done last time. So let's do check. So let's do square root of 89 over 16 plus 5 equals 2 minus the square root of y minus 4. Okay, so I'm going to use my calculator this time. So your calculator has a fraction button on it. So I'm going to do 89 divided by 16 plus 5. And then I'm going to do math frac. And it'll say that this is 169 over 16 square rooted equals 2 minus. Now I'm going to do this one also. Oops, I forgot to plug in 89 over 16 right here. Sorry about that. So 89 divided by 16 minus 4. And I'm going to do math frac once again. And it tells me this is 25 over 16, which is nice. So this is 13 over 4 equals 2 minus 5 over 4. So let's clean this up. Let's do plus 5 over 4, plus 5 over 4. So this would become 18 over 4 equals 2. Well, that is not a true statement, so this is false. So then our only solution, so we say no solutions. Okay, because our only solution that we could have got mathematically is actually extraneous. So this equation has no solution. So this is actually the correct answer. So remember, you always have to check your answers when you're dealing with radical equations that are of the even power. Sometimes cube roots and stuff, you don't have to worry as much because you can't have sneaky ones come in because there's no alternate equation. There's no principal square root or something like that. So with even roots, especially square roots, fourth roots, sixth roots, you have to be really careful and always check your work. Okay, so let's move on now to the Pythagorean theorem. You guys all know this one. If A and B are lengths of the legs of a right triangle, so it's very important that this is a right triangle only, the Pythagorean theorem only works for right triangles, and C is the length of the hypotenuse, which is the longest side across from the right angle. So notice here's the right angle, and across from it is the hypotenuse. Then a squared plus b squared equals c squared. So this is all something you guys have probably seen at some point in your life. For whatever reason, this formula everybody remembers. They don't remember the quadratic or anything like that, but everybody remembers the Pythagorean. So what the Pythagorean theorem should be used for in general for us is solving legs of a triangle, whether it's the hypotenuse or the legs somehow, or I should say solving for sides of a right triangle, okay? So here it says, find the length of the leg of a right triangle. Give the exact length and a 2 decimal approximation. So they want to know both. They want to know the exact length, and then they want to know using your calculator decimal wise what it would be. Let A equal 2 and C equal 9. So let's just draw a triangle that would be something like this. So here we have our right angle. They said C is worth 9. So we're going to say that this is 2. So this is B, and we don't know it. So all you do is you plug in what you know into this equation. So I'm going to say 2 squared plus B squared equals 9 squared. Okay, so this becomes 4 plus B squared equals 81. Let's subtract the 4, subtract the 4. B squared equals 77. Now we're going to square root both sides, just like we squared a square root to undo it. It's an opposite operation. Let's undo the squared by square rooting. So now we have B equals plus or minus the square root of 77. Now the problem with plus or minus the square root of 77 is that since this is a length of a side of a triangle, we cannot have a negative. So we kind of throw out that and we say B equals the square root of 77. Now we take out our calculator and let's do the decimal approximation. So we go second function square root 77, and we get B is approximately 8.77. They said 2 decimal places, right? Yeah. So these are both correct answers. This is the exact answer, and this is the decimal approximation. Okay, so let's come over here. Let's look at another one. Okay, so this time it says find the length of the hypotenuse of a right triangle when the length of 2 legs is 2 and 7 inches. So pause the video and you guys give this one a shot. Just make sure you know how to do the Pythagorean theorem decently. Okay, so you guys should have unpaused the video and you should have said, well, the 2 legs are 2 and 7. So I can just say 2 squared plus 7 squared equals C squared. So this is 4 plus 49 equals C squared. So this is 53 equals C squared. So let's come over here. Let's square root both sides. So we end up with C is equal to plus or minus the square root of 53. But again, this is a leg of a triangle or the hypotenuse. So we're going to say just the square root of 53. Okay. Inches. And this is the exact answer. Okay, this is exact. If they wanted to know a decimal approximation, we would just do second function square root 53. And we would get 7.28-ish. That is the approximate answer. So that's correct, depending on what they ask for. If the problem asks for exact, that means I don't want you using your calculator. I want to see if you know how to simplify radicals. Okay, so let me see. I think this is the last one for this video. So let's do a word problem. It says Evan Sachs wants to determine if the distance at a certain point, at certain points across a pond on his property. He is able to measure the distance shown on the following diagram. Find how wide the pond is to the nearest tenth of a foot. Okay. So he's trying to use a triangle to measure the distance across his pond. And the distance formula comes from the Pythagorean theorem in right triangles. So this makes a lot of sense. So right here, he happens to know this distance for whatever reason. They didn't really tell us. He knows this distance right here is 65 feet. So that's definitely our hypotenuse. And he knows that one of the legs is 40 feet. So we know we're going to use, we're going to use 40 feet squared plus B squared. And it doesn't matter if you call it A or B, equals 65 feet squared. So let's take out our calculators. let's do 40 squared. So we get 1600 plus b squared equals 65 times 65. This is 4225. Okay. So now we're going to subtract over the 1600. And we get b squared equals 2625. Now I have to square root both sides. Let's see here, square root, plus or minus. But again, we're only going to take the plus. So we get 51.2347. So they said to the nearest tenth of a foot. So we're going to say 51.2 feet. We round off. Okay, and that looks like that. Now we could have cleaned up 2625 if they had asked for exact. So this is an approximation once again. If they had asked for exact, we could have taken 2625, and we know that 2625 has a 5 in it. So 5 times 525, but we know 525 has a 5 in it. Okay, oops, not 125. This is 105. Sorry about that. And we know that has a 5 in it. So that would be 5 times 21. So because it's a square root, we're looking for 2 of a kind. Here's a pair. We use those up. So this would become 5 square roots of 5 times 21, right? Which would be 105. So the exact answer would be 5 square roots of 105. This is the exact answer simplified. So if you don't simplify in your answers, you will be marked wrong. You'll be given some credit, but you will be marked wrong if you don't simplify your answers. So this would be exact. This would be the decimal approximation. All right, you guys, that's going to do it for the video. If you need a little help with your radicals or a little review, feel free to come talk to me during our meeting times, and I will help you out with that. Thanks for watching, you guys, and I will see you in class.